Okay.
Everyone. Okay, and you can see the lesson 5 group meeting quiz, right?
Yep.
Yes.
So I believe, if I remember right now, it's actually in the homework folder. No. It's not there. Maybe I'll just email you the links because there's
Well, it's definitely somewhere because I've seen it.
Yeah, I have too, but this is the one that you really want.
Mm-hmm.
Okay, okay, I got it, the quantitative, but
sometimes there's individual ones they want you to use, like that have
yes,
the averages and stuff like that.
Yes, yes.
But those are normally
I don't remember.
when you're actually doing the homework. They've always been there.
Mm-hmm.
I
don't know if it's here or maybe it's back here.
Is to find the probabilities. Okay, it says.
Could it be in the preparation part?
Well, that's where I thought it would be. That's where I looked first, I thought. Because I went here and it just has the online textbook. And then this is a Word document.
Right.
And we already went and saw the online textbook. I didn't see a link there. I don't know. Maybe we can email each other afterwards when we find it.
Yeah.
If that's okay.
Thank you.
So we can get
Thank
started.
you very much. Okay, thank you.
Okay, so we're going to do two things, I think, for this. We need to answer that.
Oh, the applet.
And then the applet, yeah. That's what it looks like. Okay.
Okay.
So okay, so the first one is the total area under a normal distribution curve must equal 1.
Yes.
All the distributions together equal
1.
All right. Who's up?
Gabriela?
Okay, under certain circumstances, a normal distribution curve can drop below the axis. True.
I think it's false.
Oh, you think?
Because
this is the x-axis.
Just under or above, right? It says.
Yeah. This is the x-axis here. Can you see where the mouse is?
Yes.
So all of the findings are going to be above that.
Above.
None of them are going to be down here. So I think that's false.
Okay.
Does that make sense?
Thank you.
Yes.
Yes. Okay. A normal distribution curve is symmetric. True. It
agree.
is always symmetric.
Okay. Says use the following image to answer the next two questions. Says which of the following
Okay.
elements of the figure represent the z-score? Well, that's the z-score is that one, and so yeah, if it was pointing to this line, it would be this red line, but since it's not, it'd be C pointing to this one.
C. Okay.
Okay, I agree.
Okay, which of the following elements of the figure represents a probability that the z-score will be greater than 1,000?
Or that's just one.
Oh, I'm sorry, just one.
Okay, so up here,
Did you say greater than one?
right, the possibility that it's greater than one. And here we know that this z-score here is one, right?
Right. So it will be B because that will be greater.
I agree.
I agree. Okay. According to the 68, 95, 99.7% rule, what percentage of the data from a bell-shaped distribution will be within one standard deviation of the mean? Write your answer as a percentage such as 42 rather than a portion such as 0.42. Okay.
So a percentage.
Okay, 68%, but we just, okay, 68, yes.
68.
Okay.
Back to me.
Mm-hmm.
Yes.
Suppose that z-scores come from a standard normal distribution. Use the normal probability applet to answer this question. What proportion of the z-scores will be between -1 and 1? Give your answers. So aren't we looking for this here? Yeah, we are.
The middle, yeah.
And so we're going to answer to 3 decimal places. So up above the area is point, where it's 0.683.
Yes, I agree.
Okay, suppose that z-scores come from a standard normal distribution. Use the normal probability applet to answer this question. What proportion of the z-scores will be between -2 and 2? Give your answer as a decimal. So 0.954.
It would round up to 0.955, right?
Yeah.
Okay, I agree. Okay. Suppose that zeta scores come from a standard normal distribution. Use the normal probability applet to answer this question. What proportion of the z-scores will be between -3 and 3? If you answer a decimal equivalent to 3 decimal places. Okay. Okay, it would be 0.997.
Okay, look carefully at your answers to the last 3 questions. What do you observe? Well, the second one's not right because as the z-score increases, the area increases between the negative and the positive. Probability doubles, you move from Z1 to Z2. No, that's not. So the values match the rule.
Yeah. Yep, agree.
Yes, I agree.
Okay. The amount of protein that an individual must consume is differently for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of a number of grams of good quality protein that must be consumed each day per kilogram body of weight. Okay, the population mean protein requirement for adults is 0.65 grams
Of protein, right?
in protein. And the population standard deviation is 0.07 grams. So,
Sorry, let me go ahead.
it's okay. Oh, that's a question?
Yeah.
Okay. What proportion of the population have a protein requirement that is less than 0.60 grams protein? Give your answer in decimals accurate. Okay.
Okay.
So do we have to do the z-score what is it called? Z equals x, and x will be
Couldn't you look at this as? Yeah, go ahead. I'm sorry.
Oh, I'm just going for the formula right now since they have the what they call it, the mean and the standard deviation, and then they have the what is it, the observation weight, something like that. So I'm just going to use that formula that they gave, z equals x minus the mean divided by the deviation, standard deviation. And is 0.23.
You got 0.23. I think the answer is, I think that's right, but I think it's going to be 0.238.
Oh, yes. Oh, I have it here.
And so how, because we already knew what the standard deviation was, right? It was
Right.
0.07, and we knew that we were only off 0.05, right? Because the mean was 0.65 and we were 0.05. So if you just take the 0.05 divided by the 0.07, it's 0.714 z-score.
Oh, okay. That was easy.
And then you can put that in there.
Okay.
And then you're just looking at right, those people that are under that amount.
Mm-hmm.
So that area is 0.238.
All right.
You got the right answer.
Can you explain? Can you please explain it again? How did you do that?
Sure. So it looked to me, from up here, we know the z-score is how many of the standard deviation it is, right? Mm-hmm. So
yes.
A 1 z-score is 0.07, right?
Right.
That would be a 1 z-score if it was off by 0.07, but we know that it only needs to be off by 0.05 because the mean is 0.065, and down here it asks us what's less than 0.06. So the difference between 0.65 and 0.60 is 0.05. So I took that 0.05 and divide that by what we know the standard deviation to be. And it gives us a z-score of 0.714. So I put that in there. And then we want it less than that. So I looked over here, and that's 0.238.
The same answer, right? Yes, I got it. Thank you. Thank you very much. Okay. Thank you. What proportion of the population have a protein requirement that is more than 0.60 grams protein? Okay. It is because we already have the one that is less than, and now it says more than. So we can subtract 1 minus 0.238, right?
Yep, that's exactly right.
Okay. Will be 0.762. Okay.
And the only reason that I'm doing it in the applet here, because that's absolutely right, that answer.
Yeah.
But if the rounding was different from the applet, we'll want to use it. So if you'll notice, we were here, and what you said is it's the opposite of this, right? It's everything but this. So we went boom and boom, got rid of this, and that's the 0.7624.
Okay, thank you.
Okay, what proportion of the population have a protein requirement that is less than 0.7? Well, that's easy. That's going to be, this is the same z-score, and it's less than 0.7. It's the same answer. Does that make sense?
Yes, because the distance is the same as it was with 60, right?
Right. Yeah, it's just the other way.
Yeah.
Okay. Okay, thank you.
All right. Find the probability that a randomly selected person will have a protein requirement that is between 0.60 and 0.70 grams protein. Hint, remember that to find the area between two values, shade to the left of each z-scores you calculate and then subtract the smaller area from the larger area. Make sure your answer is positive. That is the probability that a randomly selected observation will lie between the two values. Okay, give your answer as a decimal.
Well, I don't like what they said to do. They said didn't they say to shade this and this, and then subtract this from one? But why would we do that when we can just do that?
Yeah. And yeah.
Everybody agree?
Yep.
Oh, I agree.
Yeah, it was, when they
that.
worked it out like that, it was a little confusing. I mean, that's a lot of steps there for that simple answer.
Okay. Find the 35th percentile for the protein requirement for adults. Round your answer to 3 decimal places. Okay, 35th percentile, it would be 0.3500. So first we how do you say, we in the
Well,
apple. Sorry.
Go ahead. I'm sorry. Go
Okay.
ahead.
The thing we have to shade the bottom part. So let me check. We can shade the left part. The left part of the apple. Can you
want to shade
please do
that?
it? Yes, I think. And the middle, not the middle, not the center. Okay. Now, at the above, we write 0.3500. Okay. Now we have the z-score that would be 0.385, right? Now we do the formula that we learned. We find the x, and it would be in the left part minus 0.385 equals x minus 0.65 divided by 0.07. And then we do the math here, and it would be the answer. I'm not if I got it right, okay? It would be the answer 0.623, but I'm not sure. Okay, you are typing there, right?
No, I think that's absolutely right.
You think I'm right?
Yep. Because its formula is minus 0.385 times 0.07. This is what you said, right? Just like that?
Yes.
Okay.
Plus, yes, you got it. It's okay.
So 0.385 minus, and I think you're right. I think you're absolutely right. Yeah.
Okay. What do you think,
Oh, yeah.
Gabriela?
I got the same 0.623.
2, 3. Okay,
Yeah.
thank you.
Okay.
Okay.
Okay. Find the 80th percentile for the protein requirement for adults around your answer to decimals. So, okay, the z will be 0.80 right there. So we're gonna find x. So I'll just go ahead and do the z score formula here. So I got 0.709.
I agree.
I agree.
All right.
Okay, we ready to submit this?
Yep.
Yes.
All right. Good job, guys.
Oh, okay, thank you. Oh.
And then
Good. Another week.
Yes.
you wanted to look
Okay.
at the question, right?
Yes, please. The homework, lesson 4 homework, number 8. I tried to find the answer, but I couldn't.
Well, the answer's right here, right? But
Yes, the answer, I got the answer, but I didn't know how to get that answer.
let's see. I don't know what the question is. Let's look.
Yeah, I haven't gotten to my homework yet on that
Yeah, me
part.
neither.
Okay, the value that it is, minus 10%, the value that we have to find will be 0.14. Okay, that's the answer for the 7th one. Now it says, using the information in the table, determine the probability that McDonald's stock will go up by less than 16% over the next year. Oh, I didn't know. Or I was thinking if I have to use the quantitative sheet.
Yeah, you might need to. I'd have to read through this. Does it tell you to use anything? Not really.
What? Sorry?
It doesn't tell you to use that, but
No, it doesn't tell about it.
I think I would use it, that quantitative in
yeah, I
Excel.
think so too.
Make it easier on you.
Okay.
Yeah. Unfortunately, I don't know right away, but I think that, if you use that, it'd make it easy and give you the answer. So, and I kind of need to run. So,
Yeah.
Okay.
All right.
Okay.
Well,
if you don't figure it out, feel free to give us an email. Okay. And when I'm actually doing it, if I figure it out, I'll kind of.
Okay.
I don't think we're supposed to share answers on the homework, but we can share resources on how we got there. So.
Yes, I think. Thank you. Thank you very much. And if you find the Excel sheets that I told you at the beginning,
I'm not sure which ones they were. You email us and if it says what the name, if you want to go back and tell us the name of it.
If you remember.
Okay. Oh, okay. I'm not sure if it was. Okay, I will email you the name. I wrote it. I will find it. And maybe you can help me to find that Excel spreadsheet, please.
All right. Yeah. Just let us know what's the name of it if you know it. And
okay. Thank you very much.
Okay. You're welcome. I'll see you. Thanks.
Bye-bye.
Bye.